Evening, welcome to my talk. In this talk, I'm planning to showcase some of the learnings that I had while creating a chatbot using LangChain. My name is Deepak, and I'm a software engineer and consultant at Tarka Labs. So, what exactly is LangChain? LangChain is a framework for building apps using LLMs. I'm sure most of you here would have interacted with an LLM, like ChatGPT is an LLM. LLM is a large language model which has been trained with a vast amount of public data. And the way that you will interact with an LLM is by supplying your input text as an input, and you will create something called as a prompt. You will pass a prompt, and based on the prompt, it will try to understand what the prompt is, and based on the knowledge that it has gained, it will respond back with a generated output text. So now the question is, since LLMs are trained with public data, how will you augment it with private data? Now, when I say private data, I don't mean you should augment it with your sensitive data. Don't do that. But data, something like you have a wiki with your domain, and you want to leverage the power of ChatGPT or some other LLM, make it understand something that's in your domain, and ask questions to it, and then see how it can answer questions to your domain. So for stuff like that, you have a method in which you can train your LLMs using a technique called fine tuning. So fine tuning is a technique that allows you to take a snapshot of an existing LLM and you train that LLM with your private data. And when the training is done, you can ask questions to it. But there are some downsides to fine tuning. So when it comes to fine tuning, it is a very complex process, meaning first you have to understand the nuances of how you can train a neural network. And that is a pretty challenging task because you have to understand the concepts of how you can train a neural network. And this space is something that's still evolving. People are finding different techniques on how you can fine tune your model. And since these LLMs are something that are very huge, training these LLMs would involve a very high cost overhead. So these are some of the downsides of fine tuning, and this process and this field is still evolving. Alternatively, you can use a technique called in context learning. So what is in context learning? You can add more stuff, like you can add more context to your prompt, and then you can submit your prompt along with your context to your language model, and then you can ask questions to it. So there is a downside to this approach. The downside is you are limited by your token limit. So when you're interacting with an LLM, you will supply a prompt, and the prompt has a fixed number of token length that you can supply. With ChatGPT, the token length is about 4096, but different LLMs and different services have their own limitation on how many tokens that you can pass along with the prompt. So this is the downside of in-context learning. Some of the popular libraries that are there, which are doing in-context learning, are LangChain and Llama Index. This list is growing, but at the moment, these two are the most popular in-context learning libraries that are there. So next, I want to talk about LangChain. So this is a overview diagram of how you would interact with an LLM. So you have a prompt on your left, you submit your prompt to LLM, and then it gives back the response. The whole LangChain ecosystem and the tooling that it supports, it falls in these two areas, in the prompt and in the response. It has toolings that will allow you to construct your prompt in different ways, and it has tools with which you can construct your prompt from different sources. And you will submit this prompt to your LLM, and it has tools, and it has helper functions that with which you can transform your response. So LangChain entirely falls in this domain where you can where it helps you to build your prompt in different ways, and it will allow you to modify your response in different ways. Some of the components in LangChain, they can be broadly classified into these topics. So first you have models. Models are nothing but wrappers around existing language models. Like say right now the most popular language model is by OpenAI, which is ChatGPT. If you use LangChain, there is a class for OpenAI which you can use to query with OpenAI. So this is just like a wrapper component on existing large language models. But if you plan to build your own LLM, you can follow the methods in this interface, and you can create a new class for it to query against your model. The second one is data connection. Suppose if you have a database and you want to construct your prompt from querying the database. So in this case, you need connectors which will talk to your database, and then your prompt has to be dynamically constructed. So for stuff like this, you can rely on data connection, the helpers and the classes that are available in data connection. The third component that LangChain gives are chains. Chains are nothing but wrappers on LLMs, like the models and the prompt template. So you can combine both the prompt template and an LLM model, and you can form a chain. Using a chain, you can query the LLM with whatever information that you want to ask, and also you can combine multiple chains together and run them in a sequential manner, or like in different ways you can combine them. All of this is abstracted in the chains package. And then you have agents. Agents are these constructs in LangChain which will allow you to dynamically select what you want to do. Suppose if you are going to ask a question to this agent, you will create this agent by creating a multiple chains and assigning these chains to this agent. And for these chains, you will write some description. Hey, this chain will do this, chain 2 will do this. Now, when you ask a question to this agent, the agent will in turn ask an LLM, someone has asked me this question, and these are the chains that I have, and these are the descriptions for these chains and what they can do. Now, the agent will ask the LLM, and it will supply the descriptions. Then the LLM will respond back saying, for this operation, you can use this chain. For this operation, you can use this chain. Based on the output that it receives from an LLM, it can dynamically dispatch your request to different LLM chains that it has under the cover. So this is very powerful. And how you can construct agent, all of this is abstracted inside the agents package. Next, you have memory. For memory, if you want to utilize, like you call the chain with some question, then you call the chain again with question number 2. So in this case, the question number 1 has to be persisted in some state, right? So this is the state with which your question number 2 has to be answered. For stuff like that, LangChain has primitives which support storing memory in a temporary fashion, or like in a rolling basis. It has different sorts of memory packages with which you can manipulate and store your state. Broadly, these are the components that are available in LangChain. Okay, so now let's look at a use case where you will try to write an app. The app will generate a business name, and you will write some keywords to this text box. You will submit what your business is doing. In turn, this app is going to rely on an LLM to generate a business name for you. So let's see how you will solve this with LangChain. So on line number 1, you can see that I'm importing some primitives from LangChain. I'm importing primitives like prompt template, OpenAI, and LLM chain. So on the second line, I'm creating a template. The template is what is a good name for a company that makes this product. And if you see, the product is a variable in this template. It sort of is like a handlebar template, you can say. But the product that you supply will be substituted on this template. Let's see how this works. So we'll move to line number 3. In line number 3, I'm creating a model. I'm creating the OpenAI model instance, but this is just an interface, not the model itself. So using this interface, I'm going to query the LLM. Okay, in line number 4, I'm creating an LLM chain instance. To this LLM chain instance, I'm supplying the LLM, the model instance on line number 5, which is the LLM equals LLM. And in the next line, I'm supplying the prompt template, which prompt template it has to use. Now in the last line, I'm going to invoke this chain by passing the argument, which is colorful cars. So the question that I'm posing for the LLM is, what is a good name for a company that makes colorful cars? So the colorful cars string will be substituted inside your prompt template, and this will be submitted to your LLM. And the response that you will get from an LLM is at the bottom. The text part of the hash that you see is the response. It says rainbow rates. So this is sort of like the approach which LangChain allows you to play around with LLMs. So with LangChain, you have other constructs where it will allow you to have a predefined template for you to use. So in this case, the template that I'm showing you is a retrieval QA prompt. So if I use retrieval QA chain in LangChain, it is going to use this prompt. Let's see what this prompt is doing. So in this code snippet, you can see that on line number 4, I'm defining a prompt template. or this is the prompt templates that are available in the LangChain package. I'm not defining it, it's there. So let's read this. So it says use this following piece of context to answer the question at the end. If you don't know the answer, don't try to make up a new answer. And then it has a place where you can stuff in your context, and then in line number 9 you can put your question there, and then in line number 10 it says answer here. So this is like a prompt you will construct to your LLM, and you will submit it if you want to ask questions against what you are asking the questions, the context that you supplied in line number 7. Against that context you are asking questions. So this is one example of a prompt that's available pre-built in LangChain. There are many prompts available. There are prompts that will, where you can write your math statement in English, and then it has a prompt where it shows some examples of how you can convert this English math statement into a numerical expression. There are different prompts like this. I'll suggest you guys to go and check out what are the prompts that are there. If you use LangChain, you can leverage all of the prompts that are available. So for my chatbot application, I'm using one such prompt. We'll look at what it is. Okay. Another powerful feature in LangChain is that it allows you to compose multiple chains. So what is a chain? I told you a chain is nothing but a prompt and an LLM. So when you have multiple chain instances that you've created, you can chain these chains together, and you can run your prompts through a sequence of chains. On line number 1 and 2, if you can check, I'm importing a simple sequential chain. The simple sequential chain, how I'm creating a new instance, I'm passing two chains to it in line number 2, which is the synopsis chain and the review chain. So in this case, my idea is I'm going to ask LLM to generate a synopsis and then review the synopsis. It has to first generate the synopsis. The first step is to generate the synopsis, and then the second step is to generate the review. So in this case, when I invoke the LLM, which is on line number 3, I'm passing the string tragedy at sunset on the beach. So I'm asking my chain to first generate a synopsis for this text, and then pass the output from the first chain to the next chain and create a review for it. So this is how the invocation will look. If you look at the bottom, the first 3 lines that it printed are from the synopsis chain. So it created a synopsis, and that input it took and it passed it to the review chain, to the second chain. So you can chain multiple chains. It's up to you to imagine how you want to do it, and this is already, you can see how powerful this can be. So you can you can create a sequence of chains and figure out what you can do with these chains. For my chatbot application, what did I do? I relied on these entities. So first is I created a PDF document with all my domain knowledge, whatever I want to stuff in. Second, I have a vector store in which I am storing all the embeddings from my PDF document. And third, I am using these two constructs. One is the conversational retrieval chain, and second is the conversation buffer memory. Let's see how we build this. Before we move on, the next thing that we have to understand is what are embeddings. Okay, I just want to take a moment here to pause. I know I'm going too fast. If you guys have any questions, please let me know. Yeah. So since you are creating the chain instance through LangChain, it takes care of the output format, and it makes sure that the interfaces are aligning with each other, and it will pass it through them. Any other questions? Okay. So the next point that I wanted to create is like I'm using embeddings for my chatbot. I want to run you through what embeddings are. So embeddings are nothing but a vector representation or like a numerical representation of a text. So in this case, how I am generating embeddings, I have a text which is canine companion say. I'm going to pass this text to an embedding model, and the embedding model is going to read and understand this text, and then it is going to return me back a vector. So the vector will look something like that. So what is this vector? So this vector is the numerical representation of the sentence that I passed. So this vector has a meaning to it. How it is doing it, it has been trained to read multiple text and generate numerical representation. It has gone through a series of learnings, and there are other techniques before which people use, like word to vec, where they will break each and every word, and then they will create a vector representation for each word. But this is kind of like on the same lines, but it has evolved so much, and now we are passing this sentence through an embedding model, and the embedding model is returning back a vector, and this vector is the numerical representation of this sentence. So it has a meaning. Just understand that it's just not numbers, it has some meaning encoded in it. Now for my chatbot, what I did is I took the PDF document, and then I broke the PDF document into multiple chunks, and then I passed each of these chunks into the embedding model, and for each and every chunk I've received a vector associated with it, right? So nothing fancy, just simple, just broke it down into multiple pieces, passed each of the pieces into the embedding model. Now I take each of these vector that I've received for each chunk, and then I store it in a vector database called Pinecone. Just like how you will store your rows and like text in your relational database, I'm just storing all this vector information inside Pinecone. Pinecone is a database that is especially built for storing vectors. Okay, so now let's look at how this will be stored. Like, this is a way that I would like to imagine, right? Say these are the sentences that I've embedded. Now this is a three-dimensional space. Imagine this is a three-dimensional space, and these are all the sentences that I've embedded and I've stored it in my vector database. I have some sentences that represent what is a boy doing, and I have some sentences that represent about a cat and what the cat is doing. At the bottom, I have some sentences that represent information about a dog, right? On the vector database, this is how it will be stored. So imagine all these dots that you see, they are the vector embeddings, and the vector embeddings that relate to each other and they have the closest meaning, they are stored closer. Like if you see all the vectors related to a boy, they are stored close to each other, and all the vectors that are related to a cat, they are stored close to each other. Now assume that I'm going to query the vector database with this text. Like, I'm going to ask, how is my cat? I'm going to query this. How will I query? First, I have to turn this text into a vector. I have to pass it through the embedding model, and I have to get the respective vector for this. Now I will pass the vector that I got to the vector database, and I will ask, give me all the related vectors to this vector, which is the vector representing how is my cat. Now the triangle that you see is possibly the space that I am saying where the vector for how is my cat will be placed by the vector database. Now the vector database is going to look what are all the closest matching nodes, or like closest matching vectors to the vector that I am querying against, and it is going to return those vectors. So in this case, the vector that I might possibly get are, look how my sad cat is and look at my little cat. These are the two possible uh, vector embeddings that I might get back by querying the vector store. So the point that I'm trying to make is, when you're querying the vector store, you are actually querying the meaning. You are not querying the reference. Traditionally in RDBMS, what we will do, we'll query by reference. We'll have an ID, we'll query by it. But when it comes to a vector store, you are actually querying for vectors that have the closest meaning. So this is the crux of how a vector store will work, and this is the like the bottom line of how the chatbot works. Once this is grasped, I think rest of all will be very easier to follow. So I'll take a moment to pause here. If you have any questions, please let me know. It's up to you to break it however you want, but as far as I am doing, I'm breaking it by sentence. And in fact, I'm just passing my entire chunk into an embedding model, and I'm storing the chunk. But if you the suggested way is, you at least break it by sentence, because sentence has a complete meaning of some representation. So I would suggest you break it by sentence, and then pass it to the embedding model and store the vector that you received on the vector store. No, for this sentence that you pass, there will be a vector representation. It understands the sentence, right? So now when you query it, you will supply a different string and you will query it based on that string. So it will try to find what is the closest match based on the string that you query against. I have to look into it. I have not thought about it. I can look into it and update you offline. Yeah. Okay. Okay. So we can move on. So this is the flow of how my chatbot works. So offline, I told you, like, I've taken the PDF document, I've broken it to chunks, run it through the embedding model, and I've persisted in the vector store. Imagine I'm at that state. My persistence is done. Now I'm going to query my vector store with something. I want to query with some English sentence, right? So that is the first box. I'm querying it with some English word or sentence. Then in the second box, I'm going to get all the matching vectors. Uh, when I actually persist my embeddings, I also persist the metadata, which is the actual sentence itself. Now in the vector store, you can stuff as much information as possible along with your vector, and you can store it. In my case, I'm storing the original text also along with the embedding, so that when I get the vector back, I can go and see what the text that I stored is real text. Next, we'll move on to the third box. So I now have all the information, like all the from the metadata. I pulled the text. I've queried for relevant information. Now using the metadata, I've also taken the text, related text out. Now using this text, I'm going to form a prompt. I form the prompt by adding all of this information that I queried against in the context, and then I will submit it to the LLM along with the question that I'm asking, and then the LLM will respond. So this is the flow of how the chatbot works. Let's see, let's see a demo. Okay. So what I've done first is, like, I'll show you the PDF. Sure, sure, sure. Better now? Thanks. So this is my PDF document, right? So I've taken the plot of the new Spider-Man movie, which is Spider-Man into the Spider-Verse, across the Spider-Verse. I've taken the plot summary from IMDb. So this is the plot summary of that movie, right? So I've stored it in disk and I've stored it in the folder plots. Now I'm using the helper directory loader from LangChain, and I'm saying, hey, I want to load all the files which are matching this pattern, which is star PDF, all the PDFs under this folder. I want to load it and create text documents using it. So here in line number 8, what I've done is, at the end of the execution in line number 8, I've got all the documents. I've, like, parsed the documents and parsed the text out of it. It's a text representation of the document. Okay. So next I'm using the character splitter utility from LangChain, which will split the text that I have parsed from my hard disk, and it is going to split it based on 1,000 words. So when I reach line number 8, it is actually going to contain split chunks of text with 100 words each, 1,000 words each per chunk. Okay. So these are some imports I would want to. Okay. Okay. So the next thing that I'm doing is, I've taken the text out of the document, right? It's still in a textual format. I want to convert that into embeddings. I'm using a helper from LangChain which is going to call OpenAI and get the embedding. So this is on this line number 2. And then it also has some helpers for especially querying with Pinecone. Since I'm using Pinecone, I can use the Pinecone helper which will query against Pinecone database for my embeddings. Okay, so these are the two imports. So the next thing that I'm doing is I'm creating an OpenAI embedding instance, and the interesting part is happening in line number 13 to 17. So I'm passing the documents that are split in line number 14, and then I'm saying, hey, for creating the embeddings out of these splits, you have to use this function which is coming from OpenAI embeddings, and then store it in this index. So when I run this, automatically your helpers from LangChain will take the chunk of document, pass it through the embedding, and it will store it inside the Pinecone database. Remember, all of these helpers are coming from LangChain. I did not write any piece of code, just utilizing all of the helpers from LangChain. Okay, so now that I've stored it in my vector database, I want to query it and see what it is responding. So this is just a pure database lookup on the vector store. So if you guys have watched Spider-Man, you know that Spot is the name of a villain who comes in the movie. So I'm asking this query, who is Spot, and it is going to query the vector store, and it is going to return me all the related embeddings related to Spot. So I just want to check if my setup is working, right? So now I queried it, and it is returning me all the information related to Spot. All of these are chunks related to Spot. The original document contains a lot of text, but it has only returned me information related to Spot. Okay, so now I've got this. Now I know my embeddings are working correct, and my database is returning the correct response. So just I wanted to do a smoke check. Okay, now let's move on. Next, I am importing the retrieval QA chain from LangChain, and to my retrieval QA chain, I'm saying, hey, use the OpenAI LLM for your interaction, and the chain type is stuff, and use my Pinecone database as your retriever, right? So the chain type, there are different chain types for retrieval QA. The one that I'm using here is stuff. Stuff means fetch all the information from the Pinecone database and stuff it in your prompt. It's not going to do any other analysis, or it's not going to do anything else. It's just going to stuff all of this information inside your context. Okay, so now I have the chain. Remember, the chain is dependent on the OpenAI embeddings which is stored on Pinecone, and then the chain that I'm using is the LLM chain which is relying on OpenAI, and then I'm saying for this prompt just stuff everything that you get from the database. That's all I'm doing. Next, I'm querying who is Spot. This time what it did is it queried all the documents from Pinecone, it constructed a prompt, it sent that prompt to ChatGPT, and this is the response that I got. Right? So remember, the first time you just got a chunk of text, but this time you sent all of the chunk of text that you received as context to ChatGPT, and then below the context it asks this question, for this given context, tell me the answer for who is Spot. Look how summarized ChatGPT responded for this. So it gave a very prompt or like very apt response saying Spot is a small time villain who was formerly a scientist at Alchemax, and other information about Spot, right? So this is awesome. This is really cool. I mean, I wish you could do this before, but at least it's now now it's happening. Okay, so the disadvantage of retrieval QA chain is in line number 9, I have queried who is Spot. I can do a second query and ask a different question, but the retrieval QA chain cannot remember the previous question. So it can only remember, or like you can only ask one question at a time to your retrieval QA chain. To solve this, where in case of a chatbot, you want to have a conversation, right? It has to preserve the context. So you ask, 10 questions, it has to remember the context of all the 10 questions that you asked. So for this, LangChain gives a type of prompt called conversational retrieval chain. And conversational retrieval chain can be associated with conversational buffer memory, and all the conversation you had will be stored inside the conversation buffer memory. And next time when you prompt, it will look at this memory and construct your prompt based on all the information that it had stored in this memory. So that is the key differentiating factor here. So I've created the two instances. I've created the buffer memory instance and I've created the retrieval chain. So this time I'm asking the same question. I'm asking who is Spot. It returned me an answer which is highlighted from here to here. This is the answer. So next time I'm not saying, I'm just saying how did he die. I'm not saying who is he, right? Spider-Man has a lot of characters. I'm just asking how did he die. Since I'm using the conversational retrieval chain, when the prompt was submitted for this query, it included the first question. Now ChatGPT looks at the previous question. Oh, the previous question was about Spot, and that's how it figures out who is he, and then look at how it answered. It answered Spot did not die, right? So this time it can preserve the context of all the conversations that you can have. No, so in the QA retrieval chain, I pass the dog DBS retrieval. Using this, it is going to query the embeddings. That's all I had for today. Any questions?